Okay, welcome to the final video. So here I will demonstrate test 3, the item level structure extraction from SEC taken file links. The requirement correctly point out that while the SEC has a specified structure, the actual formats vary enormously. So if we simply throw a massive 10K HTML file into a raw LLM, we will hit contact limits or hallucinate boundaries and incur massive cost. So it will potentially up to dollars per filing. So to solve this, I designed a 4-stage hybrid pipeline. It's a rule-based pre-segmentation, LLM boundary refinement, validation with autofix, and finally XBRL cross-validation. So maybe let's try first. We can extract apples 2023 10K. So the grading criteria emphasize like engineering, trade-off, and cost discipline. So for about 70% of modern HTML files like this one, stage one's heuristic rules and regex can perfectly segment documentation. And notice that the metadata in the output, the total LM cost is exactly $0. And the pipeline only invokes LM if the rule-based confidence drops below 0.55, or if it finds like some suspiciously few items. The selective escalation means like my cost rises monotonically with the document's difficulty, not with our traffic volume. So yeah, there also have some maybe I can call it like uh, edge cases. So you can also see like the JSON here, like how everything will work, and XRBL will like doing some uh, cross validation. So the prompt actually specifically as how we handle incorporate by reference sections, which is the basic headache in part 3 of filings. So when the parser detects an incorporation, it doesn't just flag it. The system will actively query the SEC API to locate the corresponding proxy statement, DF14A, for that physical year. So and resolve the link. Of course, the item status that becomes that incorporated and um, resolve or yeah. So furthermore, I implemented like strict header-zone heuristic. Previously, the system falsely reflect Tesla's business sections as uh, maybe something uh, like a reference in the normal section. So by narrowing the validation check to the exact header boundary, we completely eliminate those false positives. The pipeline also cleaning classifies not applicable or like reserve status. And of course, for this kind of pipeline, we can also enable LLM to do some refinement. As I said previously, the LLM refine will only happens when the confidence score is low. And but for I've also like collect some edge cases for the evaluation. Um, let's take this for example, or for layman 2007. So I click the force LM refinement and use vision like for some uncertain boundary. So this only support like for open routing model, right? So we can actually get some data here, like you were trying to collect the data and call the LM for refinement to see if there are um, some things they are below the confidence trying to see. And of course, you can use Langsmith if you have entered the Langsmith key. It actually will call, like for now, we use Gemini 3.1 and extract some image, like something like this, like for the file, and trying to figure out if there are important messages are in the file. So it was trying to revise if actually we can get more information uh, from it. Yeah, so how do we like actually verify our results without public ground truth? In the stage 4, as you can see, like for XRPL pipeline, like post like from the SEC's official XBRL company facts API. So we do that cross-validates the extracted numeric tables. If there's a discrepancy, it flags the item for review. And to respect SEC guidelines, the feature is strictly like throttle to 10 requests per second with the proper user agent. And finally, our evaluation set intentionally stresses the system. So we test against pre-bankruptcy filings like Inrun 2000 and plain text EDGAR files from 1994. So it is precisely on this like messy legacy formats where stage 2, the LLM boundary refiner, so we'll kick it. Yeah, so it isolates like just the 500 characters around an ambiguous boundary and use them to fix the split, and also giving us high accuracy without the dotted context window. Yeah, it will take some time because like screenshots quite a lot and the files are not small. But I can sum up first. So the entire Signal-Foundry project here, like for test 3, is mainly we want to address different kinds of corner cases and scenarios, and you can just directly try out with different kinds of models or how the clicks go, and you'll see the input and output results. Of course, you can use the API part to directly code it, and you will get everything you need. So yeah, to sum up, this repository was engineered from the ground up to address the core challenges of bringing AI to production. It wasn't about just making the API call. It was about like harness engineering. So I've proved that evaluation discipline by building offline live regression suites for every task, testing against edge cases and negative hallucination triggers. And I also demonstrate like systematic thinking in text use self-healing browser agent, which uses an AI and AOM first locator strategy and a multi-stage shorter loop to recover from dynamic UI changes. And I also highlight that engineering trade-off by enforcing strict budget caps, leveraging uh, item potency caches in task 1, and using the zero cost hybrid pipeline in task 3. And most importantly, we completely eliminated silent failures by forcing the agent to verify its own answers against the raw DOM, guaranteeing honesty over hallucination. So this repo actually represents a complete production-ready blueprint for evaluation first AI system. All requirements outlines in the prompt have been made, deployed, and rigorously tested. So thank you very much for your time and looking at my work. I look forward to discussing like maybe more in the future. And yeah, so we can come back to see the results. We actually can see that actually we will enable LLM to do the refinements here, and it will like extract more data here, so we can get the more precise data here, like using the vision mode and LLM are enabled. Okay, that's all for today.